need to extra phosphate
You
group?
release energy by breaking the P off.
Okay.
When the energy is released, now you can build something. You build simple molecules and complex molecules.
Okay.
If you have complex molecules and you break them, energy from those is released and you store it as the P. So you're taking the energy from the bonds in your food and using it to make this bond. If you're going to build something, you need the energy from this bond, you break this bond, and then you can build your macromolecules. So it's like one wheel turning another wheel, actually. Let it sit for a minute. Don't make it too hard. It's like me in aerobics class. If I think about what I'm doing, I can't do it. You just have to kind of go for it. Here's another example of the same thing. Don't forget, energy lost as heat is extremely important. When you run metabolic reactions, you warm up. When you're having metabolism, you're warm. When you're dead, you're cold. You need that heat. You need that body heat. It's like energy lost, but that sounds so negative. You know, the metabolic system is not 100% efficient. All the energy from the bonds in your food is not made into that bond. Some of the energy is lost as heat. But you need that heat or your enzymes can't run. Enzymes need to be nice and warm like your body temperature or they can't run. If you're lost in Antarctica and you get colder and colder and colder, your enzymes stop running. That's why your metabolism stops, because it's not warm enough. You can't keep your body heat warm enough to run make your enzymes work. Okay, we're going to do oxidation and reduction reactions. All throughout metabolism, you're going to see oxidation and reduction reactions. How many people know about that? Very few. An oxidation reaction is when you break the food apart and you lose electrons and hydrogens. The bond breaks, the electrons that held that bond together, they're liberated. And the little h's are going to follow. They're going to come off the molecule is going to rearrange itself, and the h's are going to come off. Then you're going to gather up those electrons and hydrogens, and you're going to add them to another molecule to reduce it. Because you can't let electrons and hydrogens float around out there with nowhere to attach because they're free radicals. You don't want free radicals. When you metabolize, you make a lot of free radicals. Free radicals are charged particles floating around in your body, screwing things up. Because if it's got a charge, it's pulling on. You know, if you got a real sexy girl at a party, she's going to pull all the men toward her. That's a free radical, right? If it's got a charge, it's going to attract stuff and start pulling on your DNA and your other molecules and cause trouble. You need to bind up your free radicals so you reduce something. You're like, here, let's fix her up with Joe so she's got a guy and she leaves everybody else alone. You bind her up with somebody, tie her up. Which is also why you take things like vitamin E and antioxidants, because they bond your free radicals so that they don't cause trouble. Also, in oxidation and reduction reactions that happen throughout your metabolism, electrons and hydrogens are released, but they can also be picked up and carried to another reaction where they're used for reduction. A molecule will gain the electrons and hydrogens. The carriers are NAD and FAD. Do you recognize them as modified nucleotides? Nicotinamide adenine dinucleotide. So these are also modified nucleotides. They're little dinucleotides. This is an example of how the redox reactions happen. They're coupled reactions. Here's a molecule. The molecule breaks a bond. Electrons are liberated. The electrons might be carried by NAD or FAD to an electron acceptor, NAD or FAD. Then NAD or FAD will deliver the electrons to another reaction where they're used to reduce something. Did I get that right? Oxidation. So here's the molecule, loses an electron. That's oxidation. Here's another molecule, receives the electron. It's reduced. Okay? So this molecule got oxidized. You burn up your food. And this molecule receives the electron. It gets reduced. What ends up getting reduced? Oxygen gets reduced to water. If you add H to O2, if you add enough H's to O2, you get water. So that's just an example of redox reaction. Here's another one. The reason it says play is because if you have what's it called? You know, the little code, and go in.
The what do you call it?
See, I don't know what it's called.
Mastering.
The
Mastering.
You can play them if you open it, Mastering Microbiology. I can't really play it unless I go to another file that has the associated files with it. Okay, so we could do a experiment, a reduction of pyruvic acid and lactic acid. It's going to take us forever. Everybody's bored. This is why I hate PowerPoints. They're so boring. Even for me, they're boring. It's like there's too many of them. I could explain it better if I just write it on the board. And now it's like we're forced to use these frickin' PowerPoints. And I put too much information on, but I put all the information out. See,
Well, it is complex.
and it's complicated. It's ridiculous. It's absolutely ridiculous. All right, catabolic pathways, phosphorylation.
Hold on, let me just go.
Reads like I'm done. All right. Ugh, with all this detailed crap. All right. Two molecules important to metabolic reactions. One is ATP. We just talked about ATP and the ATP-ADP cycle or recycle. The other molecule that's important to metabolic reactions is enzymes. Why are they important? Because they catalyze the reaction. They increase the likelihood that a reaction will happen by lowering the activation energy. That's what these figures in your books are about. Lowering the activation energy. Your reaction will not just take place all by itself. If the enzyme is present and warm enough, the enzyme will help the reaction to happen at a lower energy level. The point is, why don't you want your reactions just running willy-nilly all the time? Because it's wasteful. So enzymes kind of regulate when the reactions are going to run. If you don't have the enzyme available, the reaction's not going to run. Good. Why would I be running a reaction if I didn't need to? Like, why am I going to run my washing machine if I don't have any dirty laundry? Do you run your washing machine 24 hours a day, every day? Hell no. You only run it when you have dirty laundry. Some of us have a lot of dirty laundry very frequently because we have kids. Some of us only do laundry once a week. It's regulated by the presence of the laundry and the enzyme that's needed to run the machine. So your enzymes are going to regulate your reaction, so it's not wasteful just running all the time. And we already talked about some cofactors. NAD and FAD are the important ones to remember. I think I had it up here. And FAD. Where was I? Oh, all right. That was a different one. Okay. Where am I? Yeah. Okay. And coenzyme A. Anybody heard of coenzyme A?
I heard of it, but I forgot about it.
How about CoQ? Those are all carrier enzymes. What are they doing? They're carrying electrons and hydrogens from an oxidation reaction to a reduction reaction. Some of them, your coenzymes, are going to transfer small organic molecules from glycolysis to Krebs cycle, for example. So they carry also, it's just that they carry something different. They carry small organic molecules called, in this case, acetyl. So that's why I typed it all out for you. Okay, two important molecules to metabolic reactions, ATP, because the energy is transferred. You break the phosphate bond, you get energy to build. If you do catabolism and you have energy to store, you build the bond and you store the energy in the bond. Then enzymes. Enzymes catalyze reactions. When the enzyme's present, the reaction can run. If the enzyme's not present, the reaction can't run. What determines if the enzyme's present?
Active site? No.
Your DNA. The recipe to make the enzyme is in your DNA. If the cell gets the right signal, the DNA will be copied to RNA, and the RNA will be used to make that enzyme. If you don't get the signal, DNA's gonna just hold on to the recipe and you're not gonna use it. So the signal is usually presence of the substrate. What's the signal for turning on a washing machine? Laundry's accumulating. Laundry pile's getting big. Better send the signal to make the enzyme that turns on the washing machine. All right. It doesn't make much sense right now, but perhaps it will. Okay. If you want to name an enzyme, enzymes usually have an ASE ending. You want to digest lipids, you probably need lipase. You want to digest lactose, you probably need lactase. You want to dehydrogenate something, you want to remove a hydrogen, you need a dehydrogenase. You can